In this video, I will be explaining about logical gates. Logical gates are circuits which perform logical operations. OR, and NOT are basic gates. NAND, NOR, and XOR are known as universal gates. AND gate performs multiplication operation. Here, the output is the product of inputs. OR gate performs addition operation. Here, the output is the sum of inputs. NOT gate is a inverter. It complements the input. NAND gate is a combination of both and NOT gate. Its output is the complement of the product of inputs. NOR gate. NOR gate is a combination of OR and NOT gate. The output of NOR gate is the complement of sum of inputs. XOR gate. XOR gate produces I as output if the inputs are different. It produces output as low if the inputs are same. Let's look into the simulation. Let's see. Let us see how AND gate works. This is a circuit of AND gate. If both the inputs are 0, output is also 0 or low. If any of one input is 1 or I, output is also 0. If both the inputs are I or both the inputs are 1, output is I. This means AND gate performs multiplication function. Next, OR gate. OR gate performs addition functions, which means if any one of the input is 1, then it produces I output. In this case, one input is I. In this case, both the inputs are I. In both the cases, the output was I, which means OR gate performs addition function. NOT gate. NOT gate performs inverter function. When the input is I, output is low. When the input is low, the output is I, which means NOT gate performs inverter function, or also known as complementary of the input. Let's look into the universal gates. This is a NAND gate. It acts exactly opposite to AND gate. Here, both the inputs are low, which means the product of both the inputs is 0 and the complement of 0 is 1. Therefore, the output is I. If any one of the input is 0, the product will be 0 and the complement of 0 will be 1. So, in 3 cases, NAND gives output as 1. When both the inputs are 1, it gives output as low or 0. In NOR gate produces the complement of the addition function. If both the inputs are 0, the sum of the inputs is 0 and the complement is 1. If either one of the input is 1, the output is 0 because the sum is 1 and the complement is 0. If both the inputs are 1, in this case too, the sum is 1 and the complement is 0. Let's look into the XOR gate. When both the inputs are same, it produces low. When both the inputs inputs are different, it produces I. In this case, one input is I and one input is low. It produces I. If both the inputs are low, it produces low, and if both the inputs are high, it produces high.